Morning, YouTubers. So today I'm going to be covering a topic kind of in an effort to help someone, and I think we can all learn something from this as well. And I had a guy who sent me an email asking for some advice on his welds, and most of them looked pretty good and seemed like he was struggling a little bit on his outside corner joint. So I realized that now I covered a little bit of outside corner joints in some previous video. I don't even remember where or what the title was, but I did cover it a little bit. And I mainly covered it, I believe, on thicker plate. And long story short, we're gonna look at some tips and techniques for welding thicker plate on outside corner. And this will apply to thinner plate as well. It's just that thinner is gonna be easier. Since it's one pass, and as long as you're not blowing a hole through it, you're kind of doing all right. So anyways, let's get into it. So this is 1/4 inch thick plate. If you're going to weld something like 1/4 to 1/4, you can see the pretty much gigantic amount of filler that needs to be bridged over here in order to fully weld this. And it's something to think about. Like all the times when you weld, you're not going to have like a perfect, say, 1/8 inch material to where you can just single pass weld it and everything works out great. Like the real world dictates that sometimes you got to do multi-pass welds, and this would be a good example of a high probability of a multi-pass weld. Now, a gentleman that had emailed me, his welds are looking really good, especially his fillet welds. The outside corner, he had an issue where the weld, as he went down, it would like stick to one side of the plate, and then the weld would like bridge over, and it kind of alternated, and that's very common. I believe he was using 332 rods just like this is on 1/4 inch plate, but you can see, so the size of this rod versus the amount of metal that needs to be deposited here. Okay, massive weld you have to deposit here to try and one pass this, and 332 simply isn't the rod to be doing that with. Now, his plates may have been a little bit thinner than this, but from just what I gathered from the picture, this seemed to be the scenario, and this might be something you have to weld. Well, with 332 rods, the issue you're going to have is, yeah, you can sit here and just keep cramming more and more rod in while you're going, and you might actually hit flush here, but the probability of arc blow, poor penetration, sticking the rod, I mean, pretty much you name it, you're going to have issues. So I wouldn't recommend using 332 rods on 1/4 for a weld like this. You could, yes, as a root pass, but for filling, I mean, you're going to do 3 to 5 passes. Well, we'll say 3 passes to fill this out flush, versus you could use it as a single root pass and then use a larger rod to cap this off. I mean, it's something you should think about anytime you have a large weld to do. Is A, is it really smart to be doing a single pass and trying to get it done in one pass? Odds are no. And B, how many passes should I really be doing this in? And like I said, for 1/4 inch outside corner joint, 2, maybe 3 passes tops. And I'm going to show you a couple ways to do it, but that's kind of my opinion of where you're at. When you're dealing an even thicker plate, well, obviously you might have 10, 11, 12 passes if you're welding 1 inch plate. You know, you have to do what you have to do there. So anyways, when you're welding 1/4 inch thick steel, which is the beginning of what I would consider thicker steel. I mean, for us that work in our home shops, we're not doing too much welding on 1 inch plate, if you know what I mean. We're sticking with 1/4 inch, maybe 3/8 tops. So a 1/4, you got to ask yourself, well, is 332 rod the right rod to be using? Answer, no. Is 1/8 inch rod the right rod to be using on an outside corner joint or very large weld you want to deposit? Maybe. 1/8 inch rod is going to do a pretty good job on this. You're still probably not going to be able to do it in one pass. Maybe. We'll find out in this video. Another rod that might be worth looking at is 5/32 rod. Now this rod will deposit enough metal that striking it and then running it down this, you could probably fill it up with one pass. I mean, absolute max 2. But when you're welding thick steel, you can't be afraid of, you know, higher amperage and bigger rods. Like, it's not just faster, but it may produce a better looking weld. But those are all things we're going to look at. So the first thing I'm going to do on this is I'm going to set up and I'm going to run a 332 rod and I'm going to attempt to weld this, and I'm probably going to have to circle out to the edges a little bit. We're going to see about that. It's going to be tough. I don't really know what to expect. And I'm just going to try and do it in a single pass and see what we can get. So I'll weld about a third of this as one. Don't mind the double image here. I got to find a way to set up the lenses to eliminate that. But I'm just doing like a circle E or a light circle while I'm feeding a ton of rod in. And it's difficult to tell, but I'm literally pushing and cramming that rod into the puddle to try and bring the puddle up over the edges while oscillating. It's actually pretty difficult with that small of a rod to do this, and that's why like the finished weld that you're going to see is pretty lumpy. It's very hard to be consistent. So let's talk about what we have here. So this was 332 rods ran at 95 amps. I started, kind of swirled it around sort of in a circle pattern. My tie-in at the start wasn't the best. And then I just kept going and I burned up, oh man, I would say better than half a rod. Let me grab it over here. Yeah, better than half a rod to go that far. So I would have only made it on a single rod, if I was lucky, 2/3 of the length of this. I melted over the side a little bit too much, and that's going to kind of be an issue when you're doing with these small little rods like this, especially my face was about 4 feet away from this to get you guys some good footage of that. But I don't find that running small rods on bigger plate like this really, it's harder than it should be. Like you want to focus on just keeping your arc gap right and you're dragging your puddle. Well, for this, it was difficult to really tell what was going on because I was feeding so much rod into there. And to kind of give you a better idea of what I'm talking about, when you normally stick weld, and your travel rate forward is about how fast this rod burns off. So if you watch, as I push it, imagine that the rod's disappearing because it's melting off. As I'm feeding this in, you see how it's progressing forward on its own, just as it's melting off? That's pretty normal for like your travel speed, is how fast when you're at this much of an angle, the rod melts off is about what your travel speed should be. Well, when you need to deposit, I mean, you can see the amount of metal that I put in. I'm more or less going like this and barely moving forward while burning off a ton of rod. And not only is that going to promote arc blow, issues with controlling your molten puddle, because your molten puddle is essentially, a lot bigger than it should be, at least in depth. You can also run into issues when you do that where you have penetration problems. Now, I didn't really expect to see any penetration in here anyways, but just looking at that, and let me zoom in slightly here, get a little there, that's a little bit higher detail for you, sorry about that. There's no penetration through in there, and I have a feeling that if I cut this, that the puddle is essentially gonna bridge over from this to this, and very little, there'll be, welder terms, it's called dust on the root. There's probably dust on the root of that joint because there's no fusion down there. And that's why, like, if you're gonna do 1/4 inch or thicker steel and all you got is 332, you're better off running a real hot single pass down the middle and then going over it and doing this at a slightly lower value in order to cap it off. That way you get the penetration that you want all the way down in there. Like I was running 95 for this. Try like 105 to 110, run a single pass hot, and then go back with 95 over the top. That would be what I would recommend. And I'll run that right now. So I'm gonna crank it up a little bit, and I'll probably just, I'll weld another third of this and we'll look at it. Couple quick things I'm gonna mention. One is my arc gap is a little bit too long on this, and I think my amperage is a little bit on the high side. You can see a fair amount of molten balls popping out of there. But it did run pretty good until the end. And the molten pool stayed below the top edge of the plate. So completely different results. Now ignore the spatter and all of that. But much flatter bead profile than this, much less metal deposited. Now I ran this at about 105 amps, which that seems, I don't know, maybe a little bit hot, but my travel speed from this point on increased a little bit, and you can see how I have like underfill in there. The first half of it looks really good for being flat. Now backside penetration is going to be a little bit hard for you to see on the camera, but that weld nugget is right there on the inside of that. So it's pretty much right where you want it. Now realistically, if you need internal reinforcement on something like this, you would want to leave a gap. You're really not going to see too much burn through, even if I would have cranked the amperage up. Maybe with a different rod like 6010 I could have, but 7018 that we're running, you're not going to see, without a gap, you're not going to see much penetration. But a couple things to note. One, I'm sure that this has more penetration than this. Two, if you were to run a single root pass over this, just like this, just clean up it with a grinder a little bit and then go over it with a second pass with the same rod. Again, we're using 332 rods here. Your end result will be more consistent and look better and have better penetration and be arguably stronger than just trying to one pass it. If you want to one pass this, 1/8 inch rod would be a better option to look at, or 5/32. So what we're going to do now is I'm going to start with an 1/8 inch rod down here, and I'm going to weld it as a single pass, and then once I get to this part, I'm going to weld and cap that with the 1/8 inch rod, and then we're going to take a look at everything that's produced there. Now again, this is 332 for both of these, and it's okay if you want to use a 332 rod, which, let me grab that little piece I have left of it, just to kind of show what I'm talking about here. You notice how much better that rod gets in there, okay? That's because the flux and the overall diameter of the rod is pretty small. Well, when you start looking at 1/8 inch rods, I think that's 1/8. Yep, 1/8, all right. See what can happen here? It can get down in there, but if this was angled any different, you might be like this close. Well, that's too much of an arc gap, and you're going to have issues with arc blow and everything else. So it's something to be mindful of. And then when you go to the 5/32, you can kind of see how this doesn't want to really get in there too well. So it's all things to consider. But let's get this set up, and I'll weld it 1/8 inch from, I'll do it left to right from here, and then I'll go right over here and end right here. So pay attention to how this rod, you can see the corners of the plates get consumed because the molten puddle is going up over the corner. That's kind of what you want. And then pretty soon here I run over the top of the bead. And if you watch, that molten puddle is pretty round. You just want to drag that along the top there nice and slow. If that puddle starts changing shape like a peanut or disappears, you're moving too fast or at too low of amperage. All right, just to get your bearings straight, this is the first, and I'll put it in a position. We welded this guy first. You can see that little 332 trying to fill it in there. Very, very difficult. Spill over, uneven height. Very difficult trying to put that much metal in. Well, I went and ran an 1/8 inch rod, started down there and ran it all the way from here to here, and then I cut it out. So if you look at this bead, it's still a little bit uneven, like you see this edge not quite broken down and smooth. This side, you can kind of see same thing, not quite as bad, but this is by far better than this right here. And again, if I practiced with 332, I could probably do a better job, but without even taking any effort, simply by changing the rod size looks a lot better. I mean, especially if you hit this with a grinder a little bit, it would clean right up. Now, the interesting thing, and what I expected, once I hit the point where our 332 root passes in there, look how nice and even that is for both height. There's no spillover. And then I ended right here. But that bead looks really good. That's exactly what you want to be aiming for. And that was kind of the point of me doing that, is to show that doing a root pass of a smaller rod to make sure you get the penetration and then going over it with a cap will produce a better looking weld. I mean, out of these three, obviously, which one do you want? The first one, second one? I mean, that's not too bad. Or would you like all your outside corner joints to look like that? Okay. Obviously, you're probably like me. You want it in the middle. So in order to get that, either you're going to have to, with an outside corner joint on 1/4 inch, you're either going to have to do a 2-pass weld where you're using 332 for the root, 1/8 inch for the cap. You may be able to use 1/8 inch rod for the root as well, but you would probably have to move a little bit faster. Or you can switch over and use 532 rods like I got here. And what I'm going to do, I'm going to clean up another test weld piece just like this, and we're going to run it at with the 532nd rod is a single pass, and we're going to see the results of that. Don't mind the double vision again, sorry about that. But watch that molten puddle, how it just barely goes up over the edge and everything flows out nicely. This is a lot easier to run these bigger rods on 1/4 plate. All right, had a really nice run going, and then that bastard uncle that you never want to come over to your party, Arc Blow, came over and kind of ruined everything, shut it down. So you can see that's some definite molten metal there. So you can tell the bead appearance very nice. It's not like lumped up on either side far over the plate, which is good. It's got a decent height. Penetration wise, it's pretty much right there at it. I mean, I was picking little small pieces of flux from this end, so I know that the penetration's gonna be, it's there. I mean, it's good. Now the arc blow, there's a couple reasons why that may have happened. If you notice here, and I'll get a little pointer here. Here we go. We'll use this guy. I want you to pay attention to the heat affected zone lines here. You notice how this is starting to taper up, and then right at about this point, I ended up snapping out of it because I knew that I couldn't control the puddle. I think what happened, and if you look at this line here, comes on down and then it kind of necks up a little bit. I think at about this point, I just increased my travel speed a little bit too fast, and because there wasn't any molten metal down in here, with the rod being a big rod up like this high, okay, with no metal underneath it and moving too fast in front of it, I exposed a very long arc gap, because you got to remember, inside you can see how much that rod is tipped, or is, you know, tucked away up in that tip. So you can imagine if I'm up here and I already have a built-in arc gap in the rod, I mean, you're talking possibly 3/8 arc gap, so it doesn't take much moving too fast and all of a sudden, boom, you got a monstrous arc blow, and I think that's all that happened. Had I just kept my speed a little bit slower, I would have been just fine. But this really goes to show, one, you can't be afraid of amperage when stick welding thicker material, and two, that using an appropriate rod size for what you're welding makes a lot of difference. It really does. All right, let's move onward. So I'm not going to take any arc footage of this, but I'm just going to restart over here and then just run it over and see if I can't clean this up a little bit. It wouldn't be a bad idea for you to grind this back right here with an angle grinder. That way it's thinner metal where you're tying in and you'll get better penetration. For the sake of this and most of what you and I will be welding, the ultimate strength difference isn't going to be that big, especially because we're not welding this open root anyways. All right, so let's do a little bit of book learning. And I can hear you guys from the back of the class already grumbling over it, but hey, you got to put up with it, okay? Because there's a lot that you can learn from it. So one of the things that I didn't really understand when I was learning to weld was what was an appropriate weld size. Like, I mean, you got all these different rods, you got different thicknesses, and I mean, the hard and fast rule is the weld should be as thick as your base material. So like in a case of this where we just ran these 5/32 rods at about 170 amps, our weld is about probably a little bit over, if not just a 1/4 inch thick. So the weld in thickness is the same as the base material. So in theory, if we were to stress this, odds are the weld would not fail. It would bend. It is as thick. Now, if we had a little 1/16 thick weld only on the inside, well, what's going to fail? Of course, the weld, because there's no reinforcement. There's not enough metal. But one thing that I just didn't grasp for a long time was, well, like you saw here, we just did all these welds, okay, varying amperages, varying rods. What's the right way to do it? Well, I can tell you that the more metal you deposit, generally speaking, and this is in one single pass, the poorer the grain structure of the weld will be, okay? So trying to single pass, and this heavily applies to wire welding because you got a squirt gun there. You can just hold down the trigger and keep putting down metal on metal on metal all day long, right? So stick is a little bit harder to do that, but it still does apply, and that's generally speaking, the bigger, thicker the weld you put down, the poorer the grain structure. And it has to do with how fast that molten metal solidifies. Now, 170 amps on this plate was in the ballpark of what was right for it. However, I'm willing to bet if we were to actually do a microscopic examination of this, that the grain structure of this is likely a little bit poorer than the pass we did with the 332 1/8. And it has to do with the amount of metal you're depositing. Generally speaking, the more metal, the worse the grain structure is. And that is for a single pass. And that is why it's very common to do multi-pass welds, not only to get to the proper thickness that you want of weld for the material, but so that you're not depositing one big thick, like you're taking a ladle in a forge and pouring just molten metal down in a groove. Like, you don't want that. So by layering it, produces individual beads that are of higher strength combined than one single pass. Now, for us home gamers, most of this is somewhat irrelevant. I mean, is this going to be weaker than that 1/8 inch pass on the other side? Arguably not really. I mean, the bigger issue for us at home is really going to be, does it have porosity in it? Does it have lack of fusion, undercut? Those are bigger defects for us than the difference in grain structure. But I'm giving you this information for free, mind you, just so you can think, hey, if I'm welding something critical that needs absolute strength, should I do multi-pass or single pass? And if you want the better strength, a single pass is of a really big weld odds are will destructive test worse than a 2 or 3 pass weld. It's something to think of. And again, with stick, is less likely to have diminishing returns on thicker passes or thicker rods than MIG. This is definite. When I get into my MIG series, trust me, I will blow your guys' minds in some of the testing we're going to do, that you're going to see firsthand what happens when you try and weld too big of a pass or too much metal. It doesn't work very well. So with that said, let's go on to the conclusion. All right, before I cover the conclusion, there was one more thing that I was going to mention, and that has to do with the rod sizes here. Now, obviously, for most of what we're going to weld in a home, 1/8 inch and 332 rods are going to be what we're going to use, and that's fine. Like, you don't want to be using big 5/32 rods on 1/8 inch material. You'll just blow holes, and good luck with that. So that's definitely not going to be an issue. The other thing I want to mention, which also ties in what I said previously, was all of these rods, like 7018, meets a specific spec from the American Welding Society. One of the things, and you might not believe me, but hey, I always recommend, if you don't trust something that I say, or if you don't believe me, do your research. And hey, if you can prove me wrong, awesome. I will take it as a compliment, because I can learn something. We all can learn something. So prove me wrong anytime you want. So these rods are spec'd out as a 7018 at 70,000 PSI tensile strength. Normally, these actually test in destructive testing closer to 80,000. So they actually test higher than spec. Spec says minimum. If it tests over, it's okay. There are some codes that say, hey, if this thing tests at 90,000, that's too much. So there are codes that can say nothing over, nothing under. But for this, we'll say 70,000 PSI tensile strength, commonly tests at 80. Depending on how you lay down this weld, can change the tensile strength to drop it below specification. And that has to do with why you don't generally want to take 332 rods like this little guy and sit there like you saw me do on this one right here, and just sit there pouring it in there, cramming it in there, because this will produce a weaker weld than this is. Now, is it weaker than this steel? Odds are no. But again, this is information, this is bits of cheese to chew off, to think of, is that anytime you take a small rod and just keep pouring it in there, it will produce a poorer grain structure, and it will produce weaker results than a rod run straight in with minimal feeding of it in, excessive feeding we'll call it. So what does that really mean? Well, it means that you should think about that next time you want to weld thicker plate, that maybe you should be using a more appropriate size rod for what you're welding. And it's not to say, like I said, that this right here will actually blow testing results for the rod spec. It may not, but let's be honest, what's the probability here? You saw me do these welds. Which do you think would fail first from a standpoint of strength? I bet this one. This, where I did the root pass and capped it, and this one, which is just a straight pass, I bet will be less likely to fail than this from a strength perspective, or have higher tensile strength per se. Not to mention, I don't really know what the fusion looks like in that, or I guess really any of these, but that especially, you know. And from a defect standpoint, I could almost do a weld like this blind. I mean, it's so much easier to run a bigger rod on big thick plate and get a decent looking weld that's free of defects. So all things to consider. But with that said, I mean, I hope you learned a bunch here. I know that there's a lot of information to take in on this video, and I don't expect you might have to watch it a couple times or save it and come back. But all of this stuff is important things to think of. And if you're struggling with your outside corner joints on thicker steel, try 1/8 inch or 532 rods, and make sure, like you saw in the video, that your forward travel speed is reasonably slow and you're running appropriate amperage. If you see your weld sticking to one side or the other, that's a good sign you're either traveling too fast, your amperage is too low, or you're using too small of a rod and simply not depositing enough metal, or all three. So it's just all things to think of. And with a little bit of practice, you can easily do welds like this all day without even trying with stick. It's not that hard. It just takes a little bit of experience. All right, thanks for sticking around. Till next time, guys.